Okay guys, here we are again, and in this video I'm just going to be having some fun with SolidWorks, right? So I had the question come up in class that, how would you make a spiral driven component pattern? Meaning a lot of the brushes that we've studied in class have bristles that revolve around in a spiral. So how could you do that? Well, anyway, it turned out to be a little bit more difficult than I thought, but but doing this tutorial for you give you a creative example of how to pull stuff off and how to really strategize in SolidWorks. So I'm here inside of an assembly file a little bit later in the day, so I started up some music in the background. Hope that's cool with you. Here we go. I'm going to just select the front plane inside of an assembly file. Remember to look up here in the upper left-hand corner to confirm you're in an assembly. With the plane selected, I can go to Insert Components, New Part, and I'll create a virtual component inside of this assembly file. It's called Part 11. It's right here. I can click here in the design area and then go Edit Part to turn that part on. And now I can proceed just as if I'm building a regular part file. So right click on the front plane and go Sketch, and I'm already looking normal too, so I'm just going to grab my spline tool and I'm just going to kind of draw out like that bowling pin shape from before that I did in class. And I'll set this to horizontal, and I'll set this to horizontal. I mean vertical. You know what I mean, guys. Come on, you know what I mean. There she goes. Alright. Okay, so that's that like that. Let me just quickly add a center line so that I can revolve around it. Change that to construction. Go like this. Go to features, revolve boss base. Yeah. There she goes. One bowling pin ready to go. Alright, so there's that, and I'll exit out of this part and I'll actually name the part inside my assembly bowling pin R1. And the next thing that I'm going to do is punch a little hole in the side of this thing, okay? So I have to edit it again, and the hole that I'm going to make is kind of like in the other brush project where you've got to have a hole for your component to go into, for your bristle to go into. So I'll just do this the manual way, and I'll pull a plane out here into space. I'll create a sketch on there. I'll look normal too. I'll grab a circle. I'll kind of line my circle up with the origin, and I want my bristles to start about here. Good. I'll set a dimension on there of 0.1 inches for now, and then I'll just really quickly go and change the units of measurement for this assembly file with 2 millimeters, and then I'll reset that to something I can understand. We'll call it 2 millimeters. Okay. I really should be creating custom template for my assembly files that's set to millimeters, so I don't have to keep making this maneuver. It's a little bit annoying. Anyway. There's my circle, okay, and remember that's a key circle because that's the thing that we're going to use to set our concentric mate to our bristles later on. So we have to remember that this sketch exists, and we have to plan ahead that we're going to use it later on. For now, I can just go ahead and go to extruded cut and then accept this as the thing to extrude cut. And let's take a look at the way this is working right now. It's always going in the wrong direction, so we want to flip the direction using this button here. But we can also, because we have a clean surface right here, we can also set this cut extrude to start at the surface that we want it to punch into. See that? Okay, so we set this to surface, we go to face, we select that face. Now we can have control over how deep does this cut into our part. So we're going to say 1 millimeter. Alright, and there you go, like that. Okay. So I'm happy with that. And now the time has come to figure out, okay, well, how can I get this thing to spiral around the top of this brush handle? And I'll show you how I figured it out, okay? I went to my part file, and then I go, where's the plane that cuts it in half of this thing? There it is, right plane. So I'm actually going to show, sorry, I have to show the sketch that's running this cut extrude, and I'll tell you why. It's because I want to have the availability to set a plane right at the center point of this circle, okay? So I'm going to go right plane, pull a plane up, and then click on that center point. And that's going to put that plane right in the center of my circle and also in the center of my cut extrude, okay? So good news. So that's sitting there. Now on this plane, I'm going to go ahead and I'm going to create a sketch. And it's going to be a circle. And I'm going to start it at the origin and just pull it out. And I want this thing to be, you know what, I'm going to let you decide how big you want yours to be. I don't know if it matters right now, okay? So the reason I'm setting up a circle right here is because I want to do a helix. Now, I talked about helix inside of DC3, but if you didn't take that class with me, then we'll do it again right now, okay? So what this circle does is it's going to define the absolute width of a spiral. So I've got to go to Curves, Helix, and Spiral, and I'm going to turn this tool on, and it says if you want to make a helix or spiral, you have to either select a plane, a planar face, or an edge on which to sketch a circle to define the helix cross section. That's SolidWorks speak for, hey dude, you need a circle if you want to make a helix, and we already have one. So the next one says the other option is to select a sketch that contains a single circle, and we definitely have that, okay? So just clicking on that alone, the helix magically appears. Now, there's a lot to learn about creating helixes and creating spirals, and there's several different types of them inside SolidWorks. They're either defined by pitch and revolution, height and revolution, height and pitch, or just as a spiral, okay? I'm going to leave this one on pitch and revolution. In the past, when I've used this tool in the professional world, it's been to create threads on a water bottle top, and I would get a spec sheet from the engineers where they would say, okay, you know, we have 3 revolves and we have a pitch of, say, you know, 5 millimeters or something like that, and they give you the pitch and the revolution, and then you just set your spiral to that, okay? Probably what would happen in the real world is that you would just suggest where a spiral would go and your engineers would handle it for you, but who knows. Anyway, let's just call this like this and see what we can get, okay? Now that helix is going to disappear, so you might need to show your curves. Remember this tool up here, the look at tool. You might need to view your curves in order to see the spiral that you've just made. But you'll notice that with the circle is actually nested inside of the helix and defines the absolute width. Just like I said it would, this kind of paints a little bit better picture. You can see what this spiral, you can see what this circle does for the spiral now. It tells it where, how big to be. Okay? Yeah. Okay. So there's our spiral, and we're good with that. And you can play around with this if you want. Like if you wanted to edit this thing and say, maybe for a pitch, let's do 10. Okay, let's drop it down a lot to see what we can. Now see, a smaller pitch means a smaller gap in between each revolution of the spiral. So actually want this to be kind of big. Let's say 14. Okay, cool. Number of revolutions, we could change that if we want. If we changed it to 5. Yeah, you can see we want it to actually extend up past the body of the brush. So we're gonna just I'll set it to like 10. Okay, cool. All right, now cool. Okay, so probably what you're thinking is that I'm going to take this cut extrude and then have it travel along this spiral. And I think even in class, I made that suggestion that that's how you would do it. That's not going to work, and I'll show you why. Okay, so let's just do that. Let's go to, sorry, not knit surface, features, curve-driven pattern. Select the 3D curve as the thing to pattern around. Select the feature that we want to pattern, which is the cut extrude. There you go. Okay, and you can see right away there's no preview or anything like that. So you have to kind of play around with some of these until you see a preview. And there's one right there that's kind of popped up. Okay, a couple things. The instances on this pattern are set to something really small, like 4. So if we jack that up to like say 20, it might make it a little bit more apparent what's happening. Let's actually go 50. Okay, and that'll give us just kind of more things to look at. So one thing is like look at where the pattern is. turning out, right? It's kind of floating out in space, and it's like, yeah, it's sort of following the spiral, but it's not doing exactly what we want, right? And if we approve this, it's going to fail, okay? So if I uncheck geometry pattern, a bunch of them disappear. I mean, as I play around with this thing, I realize it's just not acting right. It's not doing what I want, okay? And probably the reason, so if I approve this, let's just try it. I can't even get the preview to come back on. There it is, transform. So if I approve this, just look at where those cut extrudes are going. They're out in space. And SolidWorks doesn't like this. A cut extrude, if it doesn't have a body to go into, it's not going to work. So when I approve this, it's going to fail. It's going to say, it's going to give us the worst rebuild error that you can get, which is geometry pattern fails. It doesn't tell you why it failed. It doesn't tell you if there's a portion of your model that's just not acting right. It just says, just a fail. There's just no options available for you. Just don't do that. Anyway, okay, cool. So I think maybe the reason why this is failing is because, you know, this spiral helix doesn't actually match the profile of this revolved brush body here. Okay, so as this thing's starting to spiral around, it's offshooting off the surface of the model, and then that's causing issues where the cut extrude isn't actually hitting the model, and so it's failing right there. That's the geometry fail, is this cut extrude trying to remove material from nothing or from blank space. Okay, so then the question becomes, well, how can we get a spiral that follows along the surface of our actual brush body? Because remember, in our brush tutorial, the one I just added where we talk about component or pattern driven component patterns, in that video what we did is we did an intersection curve on the surface of our brush body, and we used that intersected curve as the guide for our cut extrude pattern. Okay, so it's getting technical. It's hard to even say it. Anyway, oh boy, no, sorry, I don't know what that was. Anyway, so the idea that I had is, well, what if I could use this spiral along with a surface? If I had a surface that was spiraling, that was running and sweeping along this spiral and intersecting this model, then I could do an intersection curve the same way I did on the brush tutorial. Okay, so I'm actually going to do that. I'm going to look here at my model, and I'm going to remember, okay, I've got front plane, which kind of lines right up with the start of that helix. I can create a sketch on that front plane. All right, and I can draw a line that goes way out in space and intersects with the model. Okay, see that, how that's looking. All right, so my idea here is I'm going to sweep this sucker along the spiral, and everywhere it hits the model, it's going to create a curve. So I'm using the same technique as what I did in the other brush tutorial. It's just now with a spiral instead of a planar surface. So I'm going to go to surfaces. I'm going to go to swept surface. Everybody should know how to use swept surface. It's pretty easy. It asks you for a profile curve, and you can just choose that. And then it asks you for a curve to sweep around, and we'll choose our spiral here. And you can see what we get. We get this big spiraling thing. Sticks up like that, okay? Good, good, good. Now, let's go ahead and approve that. It's looking pretty crazy, okay? But we're going to use that same tool we used before. It's intersection curve. It's hidden underneath convert entities. We're going to go convert entities, intersection curve, select that surface, select this surface, and go okay. Okay, then hide this surface so that you can see what you're dealing with. Let's see, hide. There you go. And let's also hide the 3D curve. Let's just approve that. There you go. And so now, through that intersection curve command that we just ran, we've got this spiral that actually sits right on the surface. So like I mentioned before, from Alias, you'd call this a curve on surface. Okay. So I'm super happy with that. I'm feeling good about that. And now I think that I'll be able to run this cut extrude along this curve. And our goal is going to be so that we can get this cut extrude to stay tangent with this curve along the surface of the model. So let's try it. Curve-driven pattern. The curve we're going to use is going to be this curve. The feature that we're going to pattern is going to be this cut extrude. And you can see here there's options for tangent to curve and align to seed. What we want is tangent to curve, so we want this thing to flow around the entire surface. So you notice that there's, if we try to hit tangent to seed, nothing happens. We're not getting a preview right now. So I just want to play around with some of these details here, and I'm going to give myself a bunch more instances, make sure that, there she goes. Okay, so at least I'm getting the preview under transform curve. There you go. I'm actually going to set this something wild like 50. Okay, cool. All right, so it's starting to spiral, okay, but it's still not tangent to the curve. So let's try to hit tangent to curve, and we notice that it fails right now. But then there's this thing down here that says face normal. Select the face on which the 3D curve lies. All right, so we know what that means. So we just need to select the face of this brush body with the curve on surface. So we select that, and there she is. Look at that. So now the cut extrude follows the spiral around the entire body using face normal to keep itself tangent to the curve that's on the surface body. I think this is making sense. Okay. Okay. Moment of truth. Come on. There she goes. All right. So now we've got a cut extrude following a spiral around our model. Okay. And we can go ahead and insert our bristle now and go from there. So I'm done with this part. I'm going to exit out of this component, and I'm going to save. And when I save, it's going to say, do you want to save the assembly plus the new part that you created? And I'm going to say, yeah, save all. Oh, come on, give me a break. I'm trying to be funny here. Okay, so now I want to insert a component, and I want to find the bristle. I don't know where this bristle is. There she is. Okay, cool. So I'm going to insert this component. There it is like that. I'll just drag it over and drop it in place. Okay, there's the bristle now. It's fixed, so I have to float it in order to move it around. Okay, so there's my bristle. All right, I just want to quickly confirm that this bristle is going to fit into this hole. This is a 2mm hole, so let me go ahead and do that. Let me edit the part, and let me go to this initial boss extrude, and let me add let me just quickly add a dimension to it. Oh, it's a convert entity, so stop doing that. It's 3mm. Let's see if we can change it to 2. Cool. Alright then. Perfect. Okay, so that thing's going to fit right into our model really easily. Okay, the only thing we have to do now is the hardest part. Oh my god, we have to set up a mate between this component and the sketch that's driving the cut extrude. So let's go ahead and do that. Remember, this was the hardest part before. First thing to do, confirm that it's floating. Go to mate. If SolidWorks automatically adds any mate selections into your mate tool, just clear them out like I just did. I'm going to grab just the edge of that. And it really just doesn't want to grab just the edge, does it? Come on. Fine. And then I'm going to grab this part here. might need to move this into place a little bit. Huh, I don't know when this happened, but it looks like I've got a lock mate that's kind of holding both these things in place. I don't know why that is. I didn't add it. You've been watching, so I'm just trying to give you guys the example. If you try to move your part and it doesn't move, then go and look at your mates and figure out if there's a problem there. So remove that mate. Okay, and then let's set up a mate between that edge and this. Boom. Alright, cool. So now anywhere I move this thing is going to stay right in there. What kind of mate did I just add? I wanted to add a concentric mate, and instead I added a coincident mate. So now when I move this thing around, it just holds itself right in place, but it spins. That's cool. No, I want to delete that. And I want to actually put a concentric mate between that arc. There you go. Okay, cool. So now this thing spins, but it also stays right in line with that, and I can shove it right over here, stick it right in that hole where it needs to be. Okay. And of course, yeah, that's off a little bit, but as opposed to trying to fix that right now, we're just going to leave it as is. Okay. Okay, cool. So now our component is in place. It's time to do the most tongue-twisting feature in SolidWorks. Pattern-driven component pattern. Okay, where is it? It's up here underneath linear component pattern. It's called pattern-driven component pattern. Okay, and the component we want to pattern is going to be this one. The driving feature is going to be the curve-driven pattern of the brush body. It's underneath bowling pin. It's curve-driven pattern. There she is. And you have to make sure to put it in the right place, so put it there. And this should do the trick. Component to pattern. There you go. Sometimes it loses itself there. And that's that. Okay, so now it's using the pattern from the brush body to run a component pattern of that. Voila. Cool. Now there's a lot of stuff getting shown here, so this is where this look at command can come in handy, right? You can show to hide sketches, and now you get just that. Okay. So this thing's really fun. Now I'm going to save my work. I'm going to save all the parts involved. Okay. And the reason why this is so fun now is because now I can go back and I can actually I can make edits to the individual components. Like, see how I've got a little 2mm. I can change this to 4. See what that does. Right? Fattens up our bristles a bunch, but it fattens up all of them. Okay? So you can make one change to one component and everything will update. Alright? And then, let's see, what else can I do? I can go up to the actual brush body, open up the features of the brush body, go to the curve pattern, edit this, confirm that I like all of this, but I can do something wild like, what if I added 25 more instances into the pattern itself? Let's approve that. Let's see if it fails. So the pattern's going to update, okay, but we need to go back to the component, or to the pattern-driven component, and update that. So the pattern's updated. Now we go back to the part file for the, or we can go to this derived curve pattern. This is the pattern-driven component pattern. Edit this, and look at just turning it on updates with the latest information, but it looks like you need to do that rebuild first, okay? Add a bunch more instances to that. So this is really fun because you get the chance to do like a really complex looking model without having to do that much work, and then you have access to editing all the little bits of it. Okay, so this is super fun. I enjoyed discovering the proper way to pull this off, and you saw it in the renderings that I sent you guys. Looks really cool, like at the end of the day, having such a complex model. Not exactly full industrial design or really anything that you'd show off at like an IDSA conference or anything, but it's important to have fun when you're doing this stuff, so that's why I made this video for you. Not quite sure how long it is, but hopefully you get some of the key points that I was trying to make in this video, which is number one, how do you make a helix or a spiral? Number two, some of the details involved with creating a pattern along that spiral. Number three, another example of this intersection curve maneuver that we did in the brush tutorial, now seen in this tutorial, used a different way with a spiral instead of a planar surface. Different ways of creating curves on surface like you would an alias. And then once you have a nicely built model, the concept of going back into the individual part files within the assembly, editing them, and then watching the updates go down. All right. Okay. Hope you guys like this one. Thanks for watching, and I'll see you later.